let's examine a routing loop that is caused via redistribution. Now, let's start off by looking here at our multiple points of redistribution. We have 1 point here, we have 2 points here, we have 3 points here. So 2 of the points are between EIGRP and OSPF. And the other point is between EIGRP and the internet. So we are bringing in this default route from our static configuration on R2. So the static route is being redistributed into EIGRP. When R1 and R2 learn about this static default route that was redistributed into EIGRP, it is going to be learned as what? An external EIGRP route with an administrative distance of 170. That's what R1 and R4 are going to see. Now, we set up redistribution on R1 and R4 because we need the users that are connected way over here to R3 to be able to access the internet. So R3 needs to learn about this default route as well. So we set up redistribution on R1 and R4, and through the use of type 5 LSAs, that information is going to be flooded throughout the OSPF domain. The problem with this, though, is that R1 is now going to learn from R4, and R4 is now going to learn from R1. You might say, well, whoop-de-doo, big deal. They already know about it. Well, hold on a second. What is the administrative distance of an OSPF learned route? Yeah, even if it's external type 5, it's still 110 the administrative distance. So in this case, is R1 going to use the external EIGRP route, or is it going to use the OSPF route that it learned from R4? Same thing with R4. Is it going to use the external EIGRP route, or is it going to use the OSPF route learned from R1? They're going to use the OSPF route. So they're pointing to each other now, and we have our routing loop. Traffic comes in from R3, goes to R1, boop, boop, goes back, boop, doop, goes back, doop, doop, goes back. There's our routing loop. Hey, it's not a circular routing loop, it's a half-moon routing loop, but it's still classified as a routing loop because traffic's being bounced back and forth between R1 and R4. But now, hold on, let's be clear here that this is not going to be a static issue saying, oh, this is the way it's going to be forever. No, because remember how redistribution occurs. You can only redistribute what's in your routing table. Right now is the external route in R1 and R4's routing table. Well, not anymore, because our OSPF routes have ended up in the routing table. So how was R1 learning from R4, and how was R4 learning from R1? Well, it was learning because those routes were being redistributed. But now that the external routes are no longer in the routing table, they can't be redistributed. So R1 and R4 have to tell each other, oh, I can't get there anymore, because they're no longer redistributing that information. So now they essentially withdraw that LSA, saying, hey, you know what, that route doesn't exist anymore, it's gone. So what do we have? We have now R1 and R4 back to having the external 170 route in their routing table. Great, everything's back to normal. But no, it's not, because then redistribution happens, and they learn from each other, and then the process happens over and over and over again. So not only do we have this routing loop that happens, we have this unstable redistribution between EIGRP and OSPF simply because of what? Administrative distances and the way that redistribution behaves. So we need to be able to recognize this issue, and the only way to recognize this is to look at your topology and understand what is happening at these different points of redistribution. You'll perform the trace route, you'll perform the ping, and you'll see that, oh, the ping's failing, or it's timing out, or trace route is showing that we keep bouncing back and forth between R1 and R4. You'll notice all that, but it's not until you look at the topology and fully understand what is happening here, what is happening here, what is happening here, will you truly be able to troubleshoot the underlying issue and solve it.